All right, guys. So now that we've covered mainly the basics of negative numbers, I said we'd go a bit into the number line, and of course, yes, the number line, as we said before, it's a line that extends to an infinite number of positive numbers, also an infinite number of negative numbers. Let's just get that over there, and it also has an infinite number of numbers in between. But obviously, we have a zero. Beyond the zero, all of this entire group is all positive numbers. So let's just put that positive numbers, and let's just put it as blue. These are all negative numbers. You know what? I'll just rewrite that just to make it a bit more clear. Negative numbers. So we have positive numbers, negative numbers, but we already discussed that we have for example, like -2 plus 5. The fact that we can simply rearrange this as 5 minus 2, and it gives us the same answer of 3. But there's another way to think of it, and it kind of you'll see what I mean. So we have our positive numbers, right? And let's connect this to something. For example, Star Wars, right? So we have the dark side, which we can represent as the negative numbers. So the negative numbers, they're negative, and positive numbers are represented as this kind of positive. It's like the opposite, basically. These are two different opposites. So negative numbers, right? You can think of them as, they're what's beyond 0. So if you think of like 3 minus 5, this problem might seem like it's impossible, but once we consider negative numbers, it starts to make sense because, 3 minus 5, we have 3, we take away 5. So let's just get a number line, because a number line is really, really helpful to kind of illustrate these negative numbers. Let's say zeros here. There's still like a big number of numbers there, but we're not going to talk about those numbers right now. So actually, no. We need those numbers. Let's redraw our number line. Whoop. And we have 1, 2, 3, 1, 2, 3, and as we mentioned, the negative numbers go in the opposite direction, and they increase in the opposite direction as well. So we start at 3. That's the amount we have. Let's count back 5. And for simplicity, I'll just let's count it aloud, one at a time. 1, 2, 3. Now we reach at 0, right? But we still have 2 more hops to go. So what else would be the most logical thing other than to do those 2 hops? So 1, 2. And we can see that, hey, -2 is the answer. So 3 minus 5 is equal to -2. And this makes sense if you think about it, because it's basically the distance between these numbers. The distance between 3 and -2 is 5, because it's 5 hops each way. So it makes sense. 3 minus 5 is -2. For example, let's try another combination. We have 8, or no, maybe not that big. Let's say 2 minus, let's think of a number, 2 minus 4. Why not? 2 minus 4. So let's try this again. We have 2. We're starting from 2. And we count back 4. 1, 2, 3, 4. And it's negative 2. Hey, that's pretty easy, right? Now let's try doing it without the number line. Because, well, the number line, it's all handy dandy, but we need to try to be more reliant on just general maths, just intuition. So if we have a problem like 3 minus 8, well, this number line doesn't have 8. I could extend it even more. I could actually just bring this number line, make it bigger, but it's not gonna be like the easiest solution. So another way I like to think about this is we have a distance of 8 and there's 3, and when I think about these problems, I also consider that 5 minus 3 is 2, and the opposite is also negative, right? And 4 minus 2 is negative 2. 4 minus 2 is 2, which is the opposite of negative 2, which was our answer here. So, we could apply that logic and say, hey, 8 minus 3 is 5. So therefore, 3 minus 8 is negative 5. And that's correct, but let's try to think of it a different way. So we have, we could split up this 8 into a 5 and a 3. So the 3 minus 3 cancels out, and we still have this negative sign, because the negative sign doesn't go away. It becomes negative 5. But feel free to think of it as either way. You could think of it as this simply, maybe it helps you visualize it better. Or you could, try to drag out the subtraction sign and make it a negative. But this is all in addition and subtraction. What if we dive into multiplication? Now here it gets a little bit more tricky because, well, let's just define multiplication quickly. We have 5 times 5. A way we could say this, and also this is just another notation for multiplication. Multiplication can also be a star. It can also be most commonly represented as an X. But whatever it is, we have our problem, 5 times 5. And we want to find the answer. Well, it's obvious. We have 5 groups of 5. We have 5, 5, 5, 5, 5. We add them all together, or we remember it, and we find out that 5 times 5 is 25. But how do we do negative numbers, Because negative 5 times 5, well, I can't do a negative 5 amount of 5s, but I can do a negative 5 plus a negative 5 plus a negative 5 plus a negative 5 plus a negative 5. But how does that work? I'm adding, I have a plus and a minus. That doesn't combine, does it? Well, if we look back here, I think one of these problems we did, but basically we said that, the plus is just, it represents like a positive, and it's like we're adding these values. So for a negative, whenever you see a plus and then a minus, you basically just get rid of the plus sign. We don't care about the plus sign. It all becomes negative. And now here comes the next problem. which is pretty common, but it's actually simple if you think about it better. What is a negative number minus another number? Well, let's say let's bring back our number line just one more time, to get the idea. And this time, we have 0, and then we have -1, -2, -3, and so on and on. Let's say we have -1, and I subtract 2. Well, whenever we subtract numbers from a number line, we always hop to the left. So if I subtract 2, that's 1, 2. So -1 minus 2, because that's a problem, remember? A subtraction problem. It becomes -3. So whenever we have a negative number subtracted by another number, they combine. Well, that's neat to know. Now I can do this. And right now, pause the video and think to yourself, what is -5 times 5 if it's just 5 negative 5s? Pause it right now, and I'll begin a countdown, 5 seconds, and then you can resume. Okay, guys, I hope you've came up to an answer. If not, that's also okay. But if you did get an answer, what you should be getting is -25. Yeah, it's the same as +25, but it's negative. Well, this notation, -5 times 5, is the same as 5 times -5. And this is due to a handy little rule called the commutative property. Basically, we can switch these around. It's also called the flip-flop property of multiplication. We can just flip these numbers, and it doesn't matter. The positioning doesn't matter. So now let's try another example. Just one more sample problem. 3 times -4. Go on and try to solve this one. Okay, well, you should have got an answer of -12. Neat, we're getting used to the negative numbers. Well, we can also go into division, but I feel like that's a topic for another video. I hope you guys learned a lot from this video, and please leave a comment or some feedback if you want to. And yeah, practice those negative numbers. Bye.